Now we are going to create a helical gear. It's an approximate design only, but let us understand the basic concept behind the helical helical gear. Let's start with the new. Before that, let's select that working directory. I tried in an XCAD for spur gear. I may try it in the inch system. Helical gear. Okay, and the helical gear, I tried one version, but I don't know. But it covers almost all the okay basics. In fact, we should start with the curve from equation or curve through. Yeah, that is to create a parametric helix curve. Okay, before that, let us draw the base. Okay, the blank of as usual the root diameter. Root diameter is 1.85, right? Okay, 85 dia. Um, and let's give the assembly. Okay, at least half an inch. Okay. Okay. This let us extrude to 1.85. Okay, no problem. Let it look 1 inch there. Okay, leave it. This is our basic gear blank. Now we are going to create a curve, datum curve using datum curve from equation. We are going to do it in the same part coordinate system. Let us edit the parametric equation. Let's assume as of now we can fiddle this value later, 1.85 R value, and C value, let us keep it 1.5, and X variable takes the value R times, okay, cos of T. This is called parametric equation. And Y takes R times sine of T, sine of T, okay, and Z is equal to C times T. Okay, let us keep it and check. There is no error in this. Okay, this curve has come, and let's keep it as it is, nothing. Okay, to worry. And then we will project this curve, this helix curve, this helix curve to this surface. Okay, and in the direction, let's see the coordinate system. Okay, in the direction of x. Okay, now let's no in this direction. This curve is come, I think so. Okay, okay. Why? Because that curve is not falling in that region. Then edit it let's select individual surface, this surface also, and let's see that this type of parametric, and it goes, we choose in the wrong direction. Let's delete it. Let's create project curve, and the curve is this one. Okay, and surface this plus this, I don't know, yeah, it's coming, and the direction is in the X. Okay, now it is come, it has come. Okay, this is actually our helix curve. Okay, now we are going to do a helical sweep using this curve, helical curve as trajectory on the surface of the, okay, let's go for helical sweep then. Okay, or otherwise let's use sweep with guide curve. Let's select the trajectory, and then sketch our profile. We are going to create the sketch profile. First, let's draw the center line. Center line is this one. I think so. This comes here. No problem, because it's a helical line, right? Let it be as it is, no problem. And we were not choosing surface. And this reference, I don't think enough to create swipe. Let us add two more. Okay, close it. Let's see whether it works. Now we are going to create the profiles from the center point. Okay, let's create one more line also then. Let's create a line from midpoint. It may be the midpoint. Okay, whether it's going to work or not, I don't know. Normal to this. Okay, normal to this. Normal to this center line. Let's keep it as it is. And this one, let us make it constructions. Now whatever we are going to create, they are all construction elements only. From this intersection point, let us hide this coordinate system and the datum planes. We don't need. Okay, now this is enough. Okay, and yeah, let's start with the profile. So let's start with the circle where it goes. Do it. Start a circle using center point, and the diameter should be the pitch diameter, right? The pitch diameter should be 2.1 inch, and another circle with yeah, with the diameter 2.3. Okay, this is outer circle of our tooth profile. We are going to use the involute gear tooth. Then let's draw a line. This is also a construction line from this at 10-degree angle. Okay, let's give that angle from this point to this point 10 degrees. Okay, and another symmetric line as usual, um, from same point at 5 degree angle. Okay, it's, yeah, any angle, no angle pointing. Escape and do it. Let's create this. Okay, somewhere, oh, and do it. Let's create this angle then. Okay, okay, where it is gone. This is not an angle. Okay, otherwise let's keep this as 95. Okay, now this is symmetric to the both the sides. Okay, now we are going to create a tangent line from the pitch circle. Let's keep, yeah, the tangent symbol has come. This is what tangent C symbol. Okay, now another line, I don't know it is visible to you guys or not. Okay, these two, this is our pressure angle, right? That angle, let's keep it 20 here also, because it plays the key role here. And again we are going to create one base circle from the same point. I don't know, it's going to revolve at the same because we are shifting the center point tangent to this line. Okay, okay, it's working. Parametric circle. Okay, and so this line, let's create a solid line. This one, let's make it solid so that we can delete the invalid segment and we can pick up the exact point. Because there are 3-4 elements intersecting. See, tangent C goes somewhere else. Let us take this element also cut. Let us see whether it, yeah, this is what the tangency point, the point at which the curve is tangent. Okay, now let us make this curve to a construction line. Okay, we are going to create a circle from this center point to the tangency point of base circle. Okay, we are going to create another circle the same radius from this center to this. Now involute here has come. As usual, let's draw this line to this. No, this time let's not do it. This time we are going to create a solid line, not construction line, and another arc from center point. Center point of this arc is this point to this intersection. Okay, now we are going to create a mirror of these two curves to the center line. Again, we are going to create an arc from the center point, and that starts from this to this. Okay, and one more arc to close this profile. Okay, so that we can extrude it as a solid from this point to this point has come. Okay, let us see. Yeah, that's why this color change. I think this sketch is enough. Yes, this is what our helical gear should be. We have achieved it. And then let us make a pattern using to make a circular pattern. We have to select axis, and here also we are going to create 21 teeth. So 360 divided by 21. Okay, that's what. That's all. We have created a helical gear. Okay, that's what our helical gear. If you increase the value of the R and the C, you can have different helix angles. That is to match with the standard sigma standards. Only to fiddle with this, because we have created parametrically. We can change it at any time. Now you see, that's why. But anyway, you can edit it. This goes somewhere else. Let's give it some point there and some point here, so that it will fall within the surface if it goes away. This is how the exact helical curve will look like. Even if you change this extrude to symmetric and keep it 2 inches, okay, and then later we can trim it, it will look nice. Okay, now this is helical gear. Now we need only 1 inch, right? So let us take this plane where we are, okay, and let us create one more plane to the front at an offset of 0.5 mm. Okay, and this datum plane will create an extrude so that we can achieve the perfect geometry. Okay, let's draw the circle from this point at anywhere, okay, this point to anywhere, and let's give this as usual 0.5. Okay, and even we don't need this. Okay, one more circle. Let's create somewhere 2.5. Now let us take it out. Remove that material. Okay, this will give better. Okay, then mirror this. Take the mirror plane. Okay, this is what our actual helical gear. Okay, let us hide all the datum planes and weave it. Looks nice, right? This is what our helical gear. Okay, thank you for watching this video.